Hi friends, today we learn about division algorithm. Okay, so first of all we recall our basic division process. So I take one example, that is 17 by 3. Okay, then 3 5s are 15 and 17 minus 15 is equals to 2. Okay, here total 4 things we have. That is, first is our original number 17. It is called dividend. It is divided by number 3. It is called divisor. Our answer is called quotient 5 and 2 is our remainder. Okay. Again 17 is called dividend. 3 is our divisor. I already written here but I just show you. This is our answer. It is called quotient and 2 is our remainder. Okay, so now I write this in one different way. That is only these 4 things. That means our dividend is here. It is divided by divisor. Answer is called quotient and remainder. Okay, total 4 thing is there. Here dividend, divisor, answer is called quotient and remainder. Okay, if we divide polynomial by polynomial, that means if our dividend is one polynomial, our divisor is one polynomial, then in quotient we also get one polynomial and in the remainder we also get one polynomial. So if we divide polynomial by polynomial, then we can get answer as a polynomial and remainder as a one different polynomial. So total 4 polynomial is there. Okay, dividend is represented by p of x, polynomial of variable x. Divisor is represented by g of x, one another polynomial. Then quotient is represented by q of x, q for quotient, and remainder is represented by r of x. Okay, dividend means p of x, divisor means g of x, quotient means q of x, and remainder means r of x. Okay, I already written this form here. That means position of p of x, g of x, q of x, and r of x. Okay, then we go for division algorithm. Again I am writing same example, that is 17 divided by 3. 3 5s are 15 and final 2 is our remainder. So how we get our original number? So if we multiply this two things, that means 3 into 5, and if we add our remainder, then we get our original numbers. 5 3s are 15 plus 2 is equals to 17, right? So in this way we can get our original number. Okay, that means we need to multiply divisor with the quotient and we can get remainder. Okay, so if we write in terms of polynomial, then this is our p of x, dividend polynomial. This is our divisor, it is represented by g of x. This is our quotient, it is represented by q of x, and plus our remainder r of x. Okay, so our division algorithm is p of x is equals to g of x into q of x plus remainder r of x. Okay, so I already written here that division algorithm. P of x is equals to g of x into q of x plus r of x. Okay, now if we divide 5 by 0, otherwise any number by 0, if 0 is present in denominator, it means this number does not exist, because division with 0, it goes to the infinite number, right? So in denominator 0 is not possible, it goes to infinite number. That's why in same way, in division of polynomial by polynomial, our q of x, that means divisor polynomial, cannot be 0, because this goes to infinite number. That's why our denominator, that means divisor, because here we can write p of x divided by g of x. So in denominator g of x is there, it cannot be 0. That's why g of x is not equals to 0. Now for r of x, if we write 3 divided by 3, 3 ones are 3, 0. If we divide 4 by 3, 3 ones are again 3, remainder 1. If we divide 5 by 3, 3 ones are 3, remainder 2. If we divide 6 by 3, 3 twos are 6, remainder 0. 7 by 3, 3 twos are 6, remainder 1. 8 by 3, 3 twos are 6, remainder 2. 9 by 3, 3 threes are 9 and 0. Now just pay attention to remainder. Here remainder 0, 1, 2, 0, 1, 2, 0. Same way 0, 1, 2, 0, 1, 2, 0, 1, 2. Okay, then this remainder is always less than the 3. This remainder is always less than 3. It can be 0, otherwise 1 and 2, but less than that divisor. Okay, we cannot get 3 as a remainder if we divide by 3. Okay, if any number we divided by 5, then we cannot get remainder 5. We can get 0, 1, 2, 3, 4 as a remainder, but we cannot get 5. So remainder is always less than that dividend, right? And if we get the remainder same, otherwise greater than the divisor, let me say if I take 18 by 3 and I'm writing 3 5s are 15, then my remainder is 3. Now if now there is a no number is remaining, right? And we get a remainder is equals to the divisor, it means that our division process is wrong. Here we take 3 5s are 15, but in place of we need to take 3 6 are 18. We need to move forward, okay, one number. So 3 6 are 18. So if we get remainder is equals to divisor, it means that we do mistake somewhere. Okay, so it cannot be 3. Otherwise if 22 by 3 and I take 3 6 are 18, then remainder 4, it greater than the divisor. So again it means that we do mistake at somewhere in our division process. Okay, because 3 6 are 18 we take, in place of we need to move forward for one number, that means we need to take next number. 3 7s are 21. So remainder is always less than the divisor. Here in case of polynomial, because here we divide polynomial by polynomial. Okay, so r of x is always less than g of x, but here r of x and g of x is both are polynomial, so we need to write in terms of degree. That's why I written here degree of rx is always less than the degree of g of x. So for r of x, means for remainder, two possibilities are there. R of x is equals to 0, otherwise degree of Rx is always less than the degree of g of x. Okay, so this is our division algorithm. Okay, so in next video we solve exercise number 2.3. Thank you.